Have you heard of NFT or non-fungible tokens? With NFT, you can represent unique assets on the blockchain. Recently, an auction of cryptos sold an NFT for more than $130,000. Yes, someone paid that much for a virtual piece of art on the Ethereum blockchain. NFT can be used to represent many other kinds of unique assets, like the virtual cats of the CryptoKitties game, some piece of virtual real estate like in Decentraland, and recently we also started to see some DeFi products being represented as NFT. And a lot of people are really excited about this combination of DeFi and NFTs. There's just so much potential there. So a big problem with NFT is that you cannot buy just a fraction of them. You either buy a whole NFT or no NFT at all. What if we could buy just a fraction of NFT? It would be a great way to create some extra liquidity for NFT markets, especially for expensive NFTs. Well, in this video, I'm going to show you how we can create a Re-Fungible Token, or just RFT, that allow you to buy just a fraction of an NFT. This is really a great example of how you can mix DeFi and NFT, two topics that are super hot in blockchain right now, so make sure to follow. And if you don't know me, I'm Julien, and on my channel EatTheBlocks, I teach DeFi, blockchain development, and how to find your first blockchain job. And before we continue, if you want to learn how to become a professional blockchain developer and how to make $100,000 per year, check out my free training down below. Okay, so let's see how Re-Fungible Tokens works. So we have an admin which will create a Re-Fungible Token smart contract. But before creating this smart contract, the first step is to buy an NFT. So this admin will buy an NFT from a seller, probably going through an exchange like Rarible or OpenSea. So the admin will buy this NFT with Ether and DAI and will receive the NFT in exchange. And after that, the admin will deploy the smart contract of the Re-Fungible token and send the NFT that he just bought before. And after that, he will start the ICO where other investors will buy some shares in the Re-Fungible token smart contract. So this investor will say DAI to the RFT contract, and in exchange they will receive some share that represent a share of NFT that is inside the RFT contract. And at the end, the admin will get all the DAI that was sent to the RFT, so that's to compensate him for having purchased the NFT before. And if there is any remaining share that weren't bought, then the shares are also sent to the admin. So in the future, anybody with a share of this RFT can go to a decentralized exchange and do some trading, so buying or selling a share of this RFT. And you can be sure of the value of the share of the RFT because this is backed by the NFT token which is inside the RFT contract. Okay, so now we understand how a Re-Fungible token works. The next step is to start the coding. Okay, so in order to start the coding, first you need to install Node.js on your computer. So you install the LTS version. It works on Mac, Linux, and Windows. And we need this in order to install Truffle, which is a framework for Solidity smart contract. And in order to install Truffle, so you go to your command line, and with npm, the package manager of Node.js, you install Truffle globally with this command. And after that, you are able to create some Truffle project like this. So here I am in my project folder, Truffle init, and it has created couple of folders and file. So we're going to write our smart contract in the contracts folder, and we're also going to do a configuration in truffle config. So I'm going to open truffle config.js, and at the very bottom I'm going to change the version of Solidity that is used. So we're going to use the latest version of Solidity 0.7.3. all right. And after, we're also going to install OpenZeppelin, which is a library for Solidity. So Solidity, which is the programming language for smart contract on Ethereum. So we initialize npm project like this. And after that, we're going to install OpenZeppelin. And we're going to install a special version of OpenZeppelin, which is compatible with Solidity 0.7. So for that, we go to the page of the NPM package of OpenZeppelin, and we go in the versions tab, and we're going to copy this version here. This is for Solidity 0.7. Back to the command line, and we specify the version. Okay, this is installed, and so next we're going to start to create our smart contract. So we're going to create a smart contract for our fungible token. We're going to call this fungible NFT.source. So that's the extension for Solidity smart contract. Okay, so let's open this. And so inside, first we specify our pragma statement. So that tells Solidity which version we want to use. So Solidity 0.7.3. After, we're going to import a couple of stuff. So in Solidity, you can import some smart contract or some definition from other file. And so we're gonna reference the library we just installed, OpenZeppelin contracts, and the path is token, then ERC 721. So ERC 721, that's a token standard for non-fungible tokens. And we're going to use the interface of this standard so that allows us to manipulate some NFT token. And we're also going to import some other stuff for ERC20. So ERC 721, this is for non-fungible token, NFT. But ERC20, this is for fungible token. And we're going to use this to manipulate the DAI token. So DAI, this is a token that will be used to buy share of our Re-Fungible token. And here we need also the interface of ERC20 to manipulate ERC20 token. And we also need the ERC20 implementation because our fungible token actually itself, it will be an ERC20. Okay, so next we define our smart contract like this, and we inherit from ERC20 like this. So that means we inherit from a lot of functionality that are defined inside OpenZeppelin contract here. So that saves us a lot of code. And after, we're going to define the variable of our smart contract. So ICO share price and ICO share supply. So as I explained in the previous section, there is a phase of the fungible token, of the fungible NFT, where people have to buy share of the NFT and they will pay with DAI. So we need to set what is the price for each share and what is the total supply for all of these share, and how can you determine these two values, where it depends on how much you bought the NFTs. For example, if you bought your NFT $100, then you can set your share price at $1 and your supplies to 100, and 100 times 1 equal the $100 that you used to buy the NFT. And there's also going to be a variable for the end of the ICO. This will be limited in time. Okay, so after, we're going to define some variable for the NFT and DAI. So first, the NFT ID. So when you manipulate an NFT, you need to specify its ID in the smart contract of the NFT, because a single NFT smart contract has several non-fungible tokens. You need to identify it. And after, we're going to have a pointer to the NFT token that we manipulate. So our fungible NFT will be for a specific NFT here, but if you want, you can make it complex and make it work with several NFT. And we're also going to have a pointer to DAI. Oops, typo here. This is ERC 721. Okay. And after, we're also going to store the address of the admin. So that's the person that buy the NFT token and send it to the fungible NFT and basically control the whole process. And after, we're going to define a constructor function. So the function that is called when we deploy the smart contract, we're going to pass a couple of arguments. So first, the name of our Re-Fungible token, then a symbol, then the address of the NFT token we're going to manipulate, Then we want to know which NFT ID we want, then the price of the ICO, then the supply of the ICO, and finally the address of DAI. And after that, we're going to instantiate the constructor of the ERC20 token because we inherit from it, and we pass it name and symbol. So now our Re-Fungible token, oops, actually I meant to call this Re-Fungible, not fungible. Mistake here. Okay, let me exit this. Not fungible, but Re-Fungible token, RFT. Okay. Here RFT. Okay, this is more clear now. And after, we're going to instantiate initialize a couple of variables. So NFT ID, then a pointer to our NFT. So for that, we use the interface of ERC721, and we pass the address of the NFT. And we also need to initialize ICO share price, as well as ICO share supply, a pointer to DAI as well. And also we store the address of the admin, so that's the deployer of this contract. Okay, so let me see if we can compile this. So I like to compile progressively as I write my smart contract to make sure that I don't make too many mistakes along the way. It's easier to fix the bug progressively. So no mistakes so far. Okay, great. So next we're going to create a function to start the ICO. So this will be called by the admin of the smart contract. So that's how we define function in Solidity. We can pass arguments. Over here we don't pass any. External, that means it can be called from outside the smart contract, from JavaScript, for example, from a web application. And here we're going to interact with the NFT contract, and we're going to transfer the NFT from the admin to our contract. And so for that, we use the transfer from function, and the from address is the center of the transaction. So that's how we know the address of the transaction in Solidity. And after, to get the address of our smart contract, we use this notation. And after, we specify the ID of the NFT. Okay, so after that, the NFT is in our contract. And second, we're going to calculate the date when the ICO ends. So for that, we use the current timestamp. So that's an integer, and we add the number of seconds in 1 week. So we're going to get the timestamp in 1 week. And so 7 days is 7 times 86,400 seconds. Okay, and it should be only the admin that call this function. So we can test for a condition with the require statement, and if the condition is not satisfied, it's going to throw an error and the transaction is going to be cancelled. So here we only want the admin, only admin. Okay, and after that we're going to create another function to buy a share of our contract, and as an argument we need to pass an integer that is the amount of share we want to buy, and this is an external function, can be called from outside. And we're going to put a couple of require statement. We want this condition to be satisfied. So first we want to make sure that the ICO is not finished yet, so the ICO end needs to be superior to 0. So by default, when we declare the ICO end variable here, by default, the value is 0. So we know that if the value is not 0, that means it was initialized here, and the ICO has started. And here the error message is ICO not started yet. Okay, and after we're gonna have another required statement where for the timestamp, we want the current timestamp to be before the end of the ICO. Otherwise, the ICO is finished and it's too late to invest. And the last required statement is we want to make sure that we still have some share available. So to get the total amount of share that were issued, we can use the total supply function. So that's a function of ERC20 that we inherited here. So even though, let me see, yeah, here we inherited from ERC20, and even though we didn't define this function total supply, we can still access it thanks to this inheritance. And so we want to make sure that everything that was issued plus the amount of share that is desired, it needs to be inferior or equal to the total amount of share that will be issued in the ICO. And the error message is not enough shares left. Okay, so after we need to calculate the amount of DAI token that will be paid by the buyer in order to buy all these shares. So for that, we define a variable and we multiply the share amount by the ICO share price. So this is the share price in terms of DAI. And after we're going to transfer this DAI, transfer from the sender of the transaction to this contract, and for the DAI amount. And finally, we're going to issue the share by using the underscore mint function of ERC20. So once again, we didn't need to define this function. This is inherited from ERC20. And so we can mint new share to the sender of the transaction. And for the amount, this is share amount that was passed as an argument. And with this, our buy share function is complete. So the last function we need to create is a function that will be called by the admin in order to withdraw the DAI token that was sent to this smart contract, as well as any remaining share that were not bought. So we're gonna call this withdraw profits. Doesn't take any argument. This is an external function, and we're gonna have a couple of required statements. So first, only the admin can call this function. Otherwise, everybody can just steal the DAI. That's not good. We also need to make sure that the ICO is finished. So for this, the current timestamp needs to be superior to ICO_n, and the error message here is ICO not finished yet. And after, we're gonna send the DAI token to the admin. So first we need to calculate the DAI balance. So for that, we use the pointer to the DAI smart contract, and with the balance of function, we can know the balance of our contract. And if somebody invested in our ICO, so this should be superior to 0. And in this case, we're going to transfer the balance to the admin. So transfer to the admin, and we transfer the whole balance. Okay. And next, we also need to send to the admin the balance of shares that were not sold to investors. So maybe we were planning to sell 100 shares, but only 50 shares were sold, where that means for the remaining 50 shares, they belong to the admin because he's the one who financed the purchase of the NFT token originally. So here we're going to call this unsold share balance. And this is the difference between the ICO share supply minus total supply. Total supply, this is the amount that was actually issued. And here, if this quantity is positive, then we're going to send this quantity to the admin. The way we create new share is with the mint function, exactly like in the buy share function. And we see mint this to the admin, and for a balance of unsold share balance. Okay, so now we need to see if it compiles. So let's try to compile again. And it works, great. So now that we have written our smart contract, the next step is to write the test. So to test our smart contract, we can use our Truffle project. So if you check all the folders in our project, you will see that there is a test folder. So Truffle has a built-in feature to allow you to test your smart contract, and that's very convenient. So when you test your smart contract, oftentimes you want to create some mocks. Mocks are simple implementation of smart contract that you interact with from your main smart contract. For example, we interact with DAI, we interact with NFT token from our contract. So we need to simulate this contract. So we're going to create first an implementation for NFT. So in contract, we're going to create this file nft.sol, and we open it and specify the pragma statement. And we need to import the ERC721 implementation of OpenZeppelin. So after we define our contract, it inherit from ERC721 from OpenZeppelin. So that way we create an ERC721 very easily. And in the constructor, we're gonna accept a name argument and also a symbol argument. And after we instantiate ERC721 like this, we forward name and symbol. Okay, and there is nothing in the body of the constructor. And after we also going to create a mint function to mint some NFT to any address we want. And we also need to specify the token ID. And we use underscore mint of ERC721. First argument is the recipient, and second argument, so contrary to ERC20, this time is not the amount, but this is the token ID. Token ID, this is any integer that we decide. ERC721 doesn't care what you pass here, it just wants to see an integer. Okay, so that's it for the mock of NFT token, and next we need to create a mock for the DAI token as well. So the pragma statement as usual. Then we're going to import the implementation of OpenZeppelin for ERC20. Then we define our contract, we make it inherit from ERC20. And for the constructor, this time it doesn't take any argument, and we call the constructor of ERC20. For the name, this is DAI stablecoin. For the symbol, this is just DAI, and an empty body. Okay, and we also need to have a mint function with the address of the recipient, and this time this is going to be the amount for the second argument. And we use the underscore mint function of ERC20 of OpenZeppelin. First argument recipient, second one the amount, and that's it. Okay, so let's make sure that everything compile. Okay, great. So next we're going to install another package of OpenZeppelin in order to easily test our smart contract. This is called test helpers. Okay, so after we're going to create our test file. So in the test directory, we're going to create rft.js. So tests are written in JavaScript, well, in Node.js exactly, with a Truffle. And after we're going to open this file, and we're going to import what we call contract artifacts. So contract artifacts are representation of our smart contract from the point of view of Truffle, and these allow us to easily deploy instance of our smart contract. You will see how it works. So first, for our Re-Fungible Token smart contract, artifacts.require. So this object artifact, this is injected to this file, to this test file by the Truffle framework. And we specify one rft.sol. And we also want NFT as well as DAI. The way we define test with truffle is we use this contract function here. We give it a name. So here, Re-Fungible Token. And after, we're going to give it a callback. So in our case, this is going to be an async callback because we're going to use the await keyword inside. And it has a single argument, which is an array of addresses used by the truffle framework to test our contract. So we're going to use it. And after, we're going to extract a couple of addresses from this array. So first one is the admin that control the ICO. Then we have 4 buyer. And for the rest, we can just ignore it. And after, we specify our individual test in it function. And we give it a name. Here we can say ICO should work. And it also has a callback. So it's also going to be an async callback in our case. And first, we're going to deploy the DAI and NFT token. So for that, we use the contract artifact that we imported above. And oh yeah, here await keyword, very important. Then same thing for the NFT, await NFT.new. And we need to give it a name and a symbol. So for example, my awesome NFT symbol, I don't know, NFT, doesn't really matter. And then we're going to mint an NFT for the admin. And the token ID will be 1. So that basically simulates the fact that the admin will buy this NFT from some exchange like OpenSea or Rarible. And we're also going to mint some DAI for all the buyer. So here we want to execute several promises, several asynchronous calls at the same time. So we use a promise in order to do it in parallel. So DAI.mint buyer 1, and after we specify the quantity. So for the quantity, actually, this is going to be the same for buyer 1, 2, 3, 4. This is going to be 25,000 DAI. So we're going to define this in a variable above, and we use Web3. So Web3 is a JavaScript library to easily interact with the Ethereum blockchain. And this is already injected by the truffle framework in your test. And so on the Web3, there are some utility functions in order to manipulate units. So on Ethereum, when you do some financial transfer of Ether or of tokens, actually you manipulate a very small quantity that we call Wei. So this is basically a cent. So for example, 1 Ether equals 10 power 18 of this Wei. So that's basically a lot of 18 0 total. And for token, this is the same thing. 1 DAI, this is actually equal to 10 power 18 of this sort of elementary DAI, if you want. So that's why we have to use this function here, and we cannot just do very simply 25,000. So it's going to transform 25,000 to a much bigger number. And this is a number that actually JavaScript cannot manipulate. So it's going to transform this into a string actually. And after that, we specify here this amount of DAI to mint. And this is going to be the same thing for the 4 buyers. So buyer 2, 3, 4. All right. And after, we are going to deploy the RFT contract. So for that, RFT new, and we're going to have a lot of arguments. So first, the name for this token, because the RFT itself, this is an ERC20 token. So we're going to say my awesome RFT, and for the symbol can be, I don't know, RFT. And then the address of the NFT token, so NFT.address, that's how you get the address in a truffle test. And after the token ID, so that's 1, because that's 1 that's the thing, the number we choose here when we created our NFT. And after the share price, so how many DAI token we need for one share in our RFT contract. So I'm just going to make it simple and just say 1. And then what is the total supply for the share of the RFT? So we're going to say 100,000. So again, we have the same problem for the way. So that's why we use this function, 100,000. And finally, the address of DAI. So DAI.address. Okay. And after, we need to call the start ICO function. So this function is going to transfer the NFT from the admin to the RFT contract. But if you remember, in Solidity, we use a function that is called transfer from. That's what we call a delegated transfer. And in order to do this, first, you need to approve another smart contract to spend your token. So in order to do this, we're going to use the NFT pointer that we created, and we're going to call the approve function. First argument is the address of the contract you want to approve. So by the way, here, this is not RFT uppercase, this is lowercase, so otherwise we override this, it doesn't work. RFT.address, and we need to specify the token ID, so that's 1. Then after, we can call the start ICO function, so RFT start ICO. All right. And after, we need to invest in the ICO. So we're going to use the addresses of the 4 buyers for this. So for that, we need to first approve the DAI token to be transferred by RFT, because we're going to pay our share with DAI token. So RFT.address, then we allow this amount, DAI amount, and we need to specify who is the sender of the transaction. So if you don't specify it, by default, this is the first address of the addresses array here. So that's basically admin. But if you want a different sender, you need to specify it here with an object. So we want the buyer to send this transaction. And after you have approved, you can call the buy share function. So RFT.buyShare, and we specify which amount we want to buy. So since the price is 1, so 1 times 25,000, this is 25,000. So we want to buy 25,000 share. And same thing here, we need to specify this is from buyer 1. Okay, and after, we're going to copy paste this for all the buyer. So for buyer 2, then from buyer 3 and 4. And after, we need to wait for the ICO to end so that we can finally test that all the token balance are correct. So the ICO time is 7 days. So of course we are going to wait 7 days, but we can cheat by manipulating our local development blockchain, because basically Truffle, when it runs this test, it runs everything on a local development blockchain, totally disconnected from the real blockchain of Ethereum. So we can do whatever we want with this blockchain. And if you remember, just before in this tutorial, I made you install an NPM package called OpenZeppelin Test Helper. And this Test Helper package has an object to manipulate the time in our local development blockchain. So for that, at the top, we are going to import a time object from this Test Helper library. So OpenZeppelin Test Helpers. Okay, so back to the bottom of our test, and we're going to manipulate the time with time.increase. We're going to advance of 1 week, so we specify this in second, 1 week plus 1 to finish the ICO. And after, we're going to withdraw the profit for the admin, so RFT.withdraw ICO profits. And once we have this, we can check the different balances. So balance share of buyer 1, so this should be 25,000. And we check this with the balance of function. Since our RFT is an ERC20 token, it has the balance of function and the balance of who of buyer 1. And same thing for buyer 2, 3, 4. 2, 3, 4. 2, 3, 4. All right. And we're going to run some assertion here. So assertion allow you to verify that a condition is true. And if the condition is not true, your test is going to fail. So balance share buyer 1. So we transform this into a string because by default, this is not returned as a string. This is an object of a library called big number. This is to manipulate numbers that are too big for JavaScript. To make it simple, you can change it into a string. And this should be equal to the share amount. That's the amount of share that we wanted to buy at the beginning of the ICO. And we do this for all the buyers. Buyers 2, 3, 4. 3, 4. All right. And we're also going to check that the admin has all the DAI token. So he's supposed to get this as a compensation because the admin is the one who spent money initially to buy the NFT token. So he should receive the DAI token from the buyer of the Re-Fungible token. So balance admin DAI. Yeah, to get the balance of DAI, we can use the DAI contract. It also has the balance of function. We want the balance of the admin, and we're going to assert that this variable, so also we transform it into a string, and this should be equal to 100,000. All right, so now we're going to run our test. Okay, so here the typo, so let me reopen this. Okay, so let's try the test again. Okay, so withdraw ICO profit is not a function, so probably that I misspelled this in rft.sol. Withdraw profit. Okay, let's change the name of this function to make it match. Withdraw ICO profit. Let's rerun the test. Okay, so some other typo here. So line 51, okay, balance. Okay, same typo here. And our test works, great! What's next in this project? So far we have the smart contract, the test, but we're still missing the front end. So you can do this as an exercise. And for this, you will need some knowledge in Web3, the JavaScript library for Ethereum, and you can check my playlist on Web3. So this is just a glimpse of what you can do by combining NFT and DeFi. There are many other possibilities like packaging some advanced DeFi products into ERC721 tokens. This makes sense if the DeFi product is very specific and non-fungible, for example, an insurance. And if you want to be able to create these mix of DeFi and NFT I'm talking about, you will need first to understand well DeFi, and you can practice by building a couple of DeFi projects with this playlist. I'll see you there.